So today what I wanted to go over was calculating the vector product, which is also known as the cross product, of two vectors when they're written in unit vector form. So this is a skill that you're going to use a lot as you kind of go through upper level classes, and you will be asked to do it from time to time in physics. So if you remember, the way that we write the cross product is A cross B. Well, the time sign, which is what we usually call it, is why we call it the cross product, but it's also known as the vector product. The reason being is that the answer to A cross B is also a vector. You might have read already near the end of chapter 2, there's also something called the dot product, or also the scalar product. And so the difference between these two operations, at least one of them, is that the vector product gives us a vector in the solution, but the dot product gives us a scalar as a solution. And that's where they get their names. So one of the things that we learn in our chapter is that we can write the magnitude of A cross B as the magnitude of A times the magnitude of B times the sine of the angle between the two vectors. Now that's only the magnitude of the cross product. And to be honest, finding that magnitude is easiest when we're given the two vectors where we know their magnitudes and their angles that they make with the x-axis, which would then allow us to find the angle between the two vectors because we would just subtract. But when we have the vectors in unit vector form, it's a little bit more involved. Like, how do we put that into this expression? Which is really hard because when you have a vector in 3 dimensions, how are you going to find the angle between the two vectors? That's really hard. So we actually use a different method. And what we do is we make a matrix out of the two vectors. It's a 3 by 3 matrix. And the cross product is actually the determinant of that 3 by 3 matrix. You might have played with matrices in some of your math classes. I found as I went through high school and college, matrices would just sort of pop up in different classes and you'd learn a little bit and then you'd let it go. So maybe you've seen the idea or have had the idea of finding the determinant of a matrix. So we're going to make our matrix that's going to allow us, when we find its determinant, will give us the vector product or the cross product of A cross B. The way that we make this matrix, which again I think I already said is a 3 by 3 matrix, is the first row is the unit vectors I, j, and k, which remember point in the x, y, and z direction. Then the next row is the first vector, which for us is vector A. That's really important because as you found or read about in the chapter, the cross product is not commutative. That is, A cross B and B cross A are not the same. So order matters. The next vector or the next row is the components of A. So the x component goes here, the y component goes here, and the z component goes here. And then in the last row are the components of B, which is the x component, the y component, and then the z component. Now what we're going to do is we're going to find the determinant. Now, if you worked with matrices at all in some other context, maybe you only work with 2 by 2 matrices, which are really easy to work with in terms of finding their determinants. And what we're going to do is we're going to change this 3 by 3 matrix or determinant of a 3 by 3 matrix into a series of 2 by 2 matrices. What we're doing is we're doing what we call expanding about a row. And the row that we're expanding about here is the top row. In addition, when we do that, there's an inherent sign that goes with each of these elements of this top row. and they simply alternate. So this is a plus, this is a minus, and this is a plus. That's something to remember. Okay, so we're going to expand this 3 by 3 matrix about the top row. What does that mean? When we want to find the 2 by 2 matrix that goes with unit vector I, what we do is we eliminate the row and the column, well actually row and column, that I occupies, and we're left with these 4 numbers. So the 2 by 2 matrix here is -2, 5, and 1, and -2. So we're going to find the determinant of that 2 by 2 matrix, and that is going to be the component of A cross B, the X component, because it goes with unit vector I. Now the next thing is we do unit vector J, but remember it had that negative sign with it. And so we have to remember to put that negative sign in front of it. Now when we do the 2 by 2 matrix, we have to eliminate the row and column that J hat appears in, and that is going to leave us with these 2 numbers and these 2. So we have 3 and 5 and 2 and -2. And finally we have the K, and that 2 by 2 matrix, again, eliminate the row and column that K is in. That leaves these 4 numbers. So I have 3 -2 and 2 and 1. Now, I don't know if you remember, but when you find a determinant of a 2 by 2 matrix, you take these 2 numbers and you multiply them by each other, and then you subtract these 2 numbers multiplied by each other. So let's see what we get as we do that, moving across with all 3 of these matrices. So I get -2 times a -2, then subtract 5 times 1. Now we'll do it with J. We get 3 -2, those 2 multiplied together, -5 times 2. And then for K, just moving out of the way so you can see what I'm doing. For K, I got 3 times 1 minus a -2 times 2. Okay? Lots of writing, lots of things for me to hide behind. And so here I got I hat times 4 minus 5 minus J hat. Oop, do you see that? J, it's a J. And that's -6 minus 10. And then K hat is 3 minus a -4. All right, so I'm going to put the total up here somewhere so that I can see it. So I'm going to kind of move up here because I'm running out of room. And so A cross B, given the values that I found down below, is -I plus 16J plus 7K. And that is how we use this matrix method to calculate a cross product or a vector product of 2 vectors when they're given in unit vector form. This is a skill that, again, as I said, you're going to use frequently in your physics, and so you want to kind of get comfortable with this and so that you can use it easily when you're called upon. All right, that's it for today.